So one of the activities that I used in the class on that day is known as Predict, Observe, Explain. So this has been shown to work really well in experimental subjects such as physics. So before doing a demonstration, you get the students to predict what they think the outcome of the demonstration is going to be. And it's been shown in the literature that by committing to what they think is going to happen, they're more likely to correctly observe and remember what actually happens. So they predicted what would happen. We then did the demonstration and they observed what happened, and then we discussed and explained why that was the result of that demonstration. Another activity that we did in that class was I had a couple of small demonstrations that the students could actually physically interact with. So because these were small demonstrations, it was hard for everybody to see. So I got individual students to hold them and to describe to the class what was happening, and then we had a class discussion about why this happens. Okay, so in the physics education literature, it's been well known for over 20 years that the learning gains of students are higher when interactive engagement techniques and active learning is used. So I've seen this in my own courses. We measure the learning gains of students, so we compare how much they know before we teach them to how much they know afterwards, and considering how much they know coming in, their learning gains are relatively high, and I attribute this to using lots of active learning strategies during the lectures.
I think the activity where it was predicting what's going to happen in the experiment, as she explains to us, that being able to make a prediction means that you're going to more likely remember the result. And I've noticed that myself as well throughout the term, that we've been doing that quite frequently. I almost remember the experiments or questions I've gotten wrong so much better than the experiments I got right, because then you had to lead to some sort of justification for why you were wrong. So as opposed to just getting a wrong answer, you get sat down and told and explained through why exactly that is correct. And I also think it just makes it a little bit of fun, makes it a bit more exciting, be able to chat with your friends and see what you think is going to happen and why, and you can discuss amongst yourselves, because learning through peers, I think, again, is like one of the best ways to learn. So being able to learn together and discuss it before we vote, and then watching the experiment and seeing what's happening as it happens, and discuss if we still think we're going to be correct or incorrect, and then that debrief afterwards, I think, is really important. And also we were told to just sort of feel our chair, and that gives a real world application. So it means I can immediately, within an instant, take what I've just been told and the information I've been given and understand something about the world around me, which means I have something to connect it to. So it's again that thing of not just retaining information and being able to spit it back out, it's understanding, okay, the reason my chair feels cold is because of the material it is. And I think things like that are really important, just connecting it to your real life and making sure that you are really engaged.
Well, in this class, as I was saying, there's a lot of experiments and physical representations, which is really nice because there's a direct reference to a formula or to a concept. Whereas I see a lot in the maths lectures, there's no real life, a real life scenario that you can use it in. And there's a lot of information just chucked at us a lot of the time. And it's hard, I think, to concentrate for that 2-hour period without any sort of interaction with the students. So it's usually just a lecturer standing there going through her slides and maybe sometimes writing down how they would do it. But it's hard, I think, to concentrate for that 2-hour period and really get a good learning experience from it if you're not engaged, and you can't be engaged if there's no sort of excitement with the experiments, like, oh, what's going to happen here, and sort of, not arguing, but constructing ideas with your peers about how something's going to happen. And I think we're able to really enjoy the class and actually get more out of it as a learning experience with having a bit more of a fun time, rather than just sitting there in a 2-hour maths lecture, going from one slide to another. And I think that's what makes the class a lot more engaging and makes me actually want to go to the lectures.